Okay, good morning to everyone. We are almost starting this webinar, but just to give time to the attendants to connect. Okay, the number is increasing, so we can wait just 1 minute. Okay, after reaching 30 attendants, I think that we can start. Okay. Good morning to everyone. I am Monia Santini, researcher from the Foundation Euro-Mediterranean Center on Climate Change, CMCC, and I welcome you to this webinar held by Daniele Piazzolla, a researcher of the Division on Ocean Prediction and Applications. Daniele works on the impact assessment of anthropogenic pressure with focus on pollution, on the marine and coastal environment and ecosystems. And today he will tell us something more about the coastal areas of Mediterranean Sea and about different methodologies to monitor seagrass, which have many functions to ecosystem, which provide many functions to ecosystem and also to humans. And before starting, I would like to say a few words about the CMCC Foundation, a research center on climate science and carrying out studies and analysis and developing models on the climate system and on its interaction with the ecosystem and the society in order to produce useful results to support the formulation of climate both adaptation and mitigation policies based on scientific knowledge, in turn stimulating sustainable growth and environmental protection. And CMCC was first established as a sort of consortium company, and then it became a foundation since 2015. And its members are Italian universities, research centers, and international organizations, which allow complementing the CMCC expertise in different directions. This is also why CMCC is organized as a network of thematic centers and groups with offices distributed across Italy in Lecce, where we have our headquarters, and then in Caserta, Viterbo, Sassari, Bologna, Venezia, and Milano. These centers converge into 11 research divisions that deal with the various aspects that concern climate science, from atmosphere to ocean processes, to the interaction with terrestrial and marine ecosystem, from a biophysical and biogeochemical point of view, up to risk assessment and possible solution for the environment, the economy, and the society, all in the context of climate mitigation and adaptation pathways to tackle challenges of climate resilience and carbon neutrality. This organization allows to address in an interdisciplinary way the different issues and to consider the relationships between the natural world with its physical processes and the anthropic component. Another peculiarity of CMCC is the supercomputing center. This is operational since 2008 and hosts computing and storage facilities were upgraded last year to finalize and activate the new supercomputing center in the new CMCC headquarters. Last but not least, CMCC is particularly active in raising awareness also outside the organization through activities ranging from scientific dissemination through publication to communication to a wide audience, thanks to events, articles, and other interaction activities, not neglecting the importance of training students to continue their careers to work in the field of climate change science through PhD programs and dedicated schools. Now, some brief technical information about the webinar. The audio and video of the participant are switched off, but you can participate in the Q&A session using the appropriate chat. You can also raise your hands and I will give you the floor to talk, but I would prefer if you write your question, as I will try to condense or integrate similar questions so to optimize the time available. Daniele will try to answer live at the end, but of course also after the webinar, he will look at the list of questions by contacting you by email. For those that are not able to attend today, I would remind that the webinar will be recorded and circulated soon via the CMCC social network, including the YouTube channel. At this point, I can give the floor to Daniele, who can share his screen and start. So enjoy the webinar and see you at the end.
Thank you very much, Monia. I'm gonna share the screen.
We can see your screen, okay.
Okay. So, good morning to all. As Monia said, I'm Daniele Piazzolla. I'm from the OPA division, CMCC. And today I'm going to show you some results of our approach that we are using to monitoring coastal areas since 6 months now, and which involve specifically autonomous survey vehicles and remote operated technologies. So let me briefly introduce why it's important to study the coast. And mainly the coast can be defined as a boundary between great marine and oceanic water bodies from the mainland. But obviously this definition is quite simple. These areas host great complexity, speaking about ecosystem and also speaking about anthropogenic pressure that can affect these areas. The first characteristic of coastal areas is their extremely dynamic processes, and that are mainly due to the meteomarine events. And in this part of the screen in the right, you can see really different coastal types and also shorelines which have been studied by Gitman and colleagues in 2015. The coastal areas are also host very ecologically important ecosystem, which provide a wide range of ecosystem services. Coastal ecosystems include the intertidal, subtidal, and above shelf areas. And these ecosystems are home of really complex chemical, physical, and biological processes. Beside the presence of ecosystem, the problem that affect coastal areas are also the anthropogenic activities which are normally present in all the coastal areas, but these areas are also dense populated because they can offer a lot of resources to the anthropogenic and the human activities in general. So the consequence is that there is a conflict between the presence of important ecological ecosystems and the presence of the human activities. So it's important to monitor these areas. It's important to preserve and act monitoring plan and politics that can prevent the destruction of the bad presence of threats in these ecosystems. In the right, you can see two of the most important Mediterranean marine ecosystem, which are the Posidonia oceanica meadows, habitat 1120 for the Natura 2000 convention, and the coralligenous bioconstructions. There are several threats that can affect these areas. We can speak about alteration of the sediment supply, excessive pollution, introduction of alien species, together with the most important climate change effects. And also, speaking about small scale, we can speak about coastal works. for example, the enlargement or structure directly present on the sea, such as harbors. So in order to act promptly and make protection and restoration of these habitats, it is necessary to know these habitats, know the ecology, and characterize the extension in the geographical areas. So there are several techniques and methodologies which falls inside the meaning of habitat mapping, which is strictly the analysis of a survey area with the to know the ecology and the habitat characteristics. And researchers and government authorities do this kind of studies, do this kind of works for several reasons. And the techniques that can be applied to have information of habitat and ecosystem are different. We can summarize that habitat mapping can be done with really two kind of big techniques: remote sensing and, specifically speaking, satellite-derived habitat characterization, or underwater acoustic surveys. The choice of these two kind of techniques is dependent of the work needs and also about the section of the area. So researchers and authorities can apply these two kind of things, two kind of methodologies depending of their needs. In the right, you can see some example of output of habitat characterization. This is from the US Department of the Interior and the National Oceanographic and Atmospheric Administration. So first of all, let me speak about a minute for the remote sensing technologies. Remote sensing technologies involve the use of several platforms. The most used one is, of course, the satellite remote sensing, which is used to cover areas bigger than 10 kilometers up to 1,000 kilometers. And secondly, area remote sensing, which is useful to cover areas from 10 to 100 kilometers. And last but not least, the use of new autonomous technologies, UAV-based remote sensing, which is good for characterization of areas more than 100 kilometers. This characterization in these images is from Xiang and colleagues in their work of 2018. So on the right, you can see the habitat map of Singapore from Tan and colleagues 2022, which characterize the immediately coastal areas of Singapore using remote sensing and specifically using satellite remote sensing. And the other example of habitat characterization is from China and is related to seagrass mapping. So the other type of technology that can be used, especially in smaller areas, so small scale surveys, is echo sounding. And echo sounding is can be divided in three types of really different technologies that can be applied. All of them use echo sounding in different ways, and the three major transducer or systems can be single beam echo sounding, side scan sonar, and multi-beam echo sounding. And below each of the three type of echo sound systems, you can see a snapshot of a type of image of echo sounding profile that can be acquired. So the first is bottom type and vegetation presence using a single beam echo sounder. The second one is a side scan sonar image, and the third is a wreck in the Harbor of Brest with the 3D multi-beam echo sounding techniques. It's important to say also that remote sensing habitat mapping can be validated using echo sounding. So they are techniques, different techniques, but correlated one with the other. So what are the problems to use especially echo sounding, so regular monitoring activities? The problem are different, and one of which is the cost of the boat. You can obviously use bigger boat, bigger oceanographic cruises for open water surveys, and small boat for more coastal surveys. But each of these have a cost and are quite expensive. So this boat need fuel, this boat need crew to be paid, and also to do all this kind of analysis, you need more time. They are time effective and cost effective. So other things is that the most of this ship can achieve small, shallow areas. So maybe you can reach from 2 meter depth, but not shallow areas than 2 meter depth with this kind of boat. And also the fuel can be a polluting agent for the ecosystem. Moreover, there is quite a big problem with the data validation, because all these kind of techniques, especially echo sounding, if you want to know strictly what type of substrate you have inducted, you need ground truth validation. Ground truth validation means that you have to use standard monitoring technique or sampling campaign that can damage directly the ecosystems. So what we can do now is using the new technologies that now are quite a lot in the field of surveys, and I'm speaking about USV, unmanned surface vehicle, that are obviously unmanned, are smaller. We can use these in areas that ships then can't surface, and also have limited cost, and also have more possibility to achieve some attributes like like the attributes that are listed in the chart, and are more user friendly for surveys instead of several of the normal and canonical platform of survey platforms. So in this chart from Liu et al. In 2016, you clearly see the advantage in green of the use of USVS instead of the several other monitoring platforms. Obviously, all the USV have to be customized for our purposes. So we use these kind of technologies inside this project, the Renovate project, which is ecosystem approach for compensation and mitigation action in coastal marine environment, which insists and have this area of application in the North Mediterranean Sea, especially near the city of Civitavecchia. The objectives of the Renovate project are several, but the three most important are listed in this slide. First of all, environmental compensation action of 1120 and 1170 habitat toward ecosystem service restoration. The prototype of a digital twin of the ocean for marine ecosystem restoration, nature-based solution implementing planning. And also the implementation of an early warning system for extreme natural events, dredging and pollution impact prevention. So these are a schematic representation of what the Renovate project involved, speaking about technologies, and these are the partner of the Renovate project. So inside this big project, we use an integrated approach, mainly based on USVS and ROV technologies, especially to characterize the areas in the vicinity of the Civitavecchia harbor. That is one of the biggest ports in Europe, especially for cruise traffic. And this harbor will be implemented with new infrastructure. In this slide, you can see the two areas that will be implemented. This is the northern end, in the northern area, the northern entrance of the port, which would be enlarged with the new breakwater, maybe of 400 meters more. And this is the southern entrance, the new southern entrance that will be built in the next year. And all these two new implementation of the port infrastructure have the problem that have to impact or at least affect some of important biogenosis. We can speak about Posidonia oceanica meadows and obviously coralligenous bioconstruction. So inside this project, we use this integrated approach to monitor the presence, to monitor the type of substrate, and to assess the possibility to recover and restore the area. So this is our workflow. And which involve the use of an unmanned surface vehicle, which I'm gonna show you in the next slide in detail. And the second step is the bottom line and vegetation assessment using specific program of the echo sounder, which is installed on the hull of the USV. And the third step is the data analysis, which involve obviously data interpolation for the bottom depth and morphology, bottom type, vegetation height and coverage. But the fourth part of the workflow is the ground truth of the bottom depth, morphology, vegetation and coverage and so on, because we must do this to assess the accuracy of our echo sounder data. And the ground truth will be done by ROV surveys and divers investigation. Specifically, ground truthing for bottom type will be done with the ROV. And for the vegetation coverage and height, we need more specific site control, so we use scientific divers. And this ground truth control will be done both in second and third steps. So this is our platform, our USV. And the small boat is an EcoBoat 160 from Sea Floor Systems. Is a HDPE mini boat, is 160 centimeter for 60 centimeter wide. And in this application, this is totally customized for our purposes. So inside we have several sensors. The most important is obviously the echo sounder, which is from Biosonics. This is a MX aquatic habitat echo sounder, which is a single beam and is strictly used for habitat mapping. This is a snapshot of what the echo sounder can give you. So you can interpret the presence of the bottom instead of vegetation, not only plants but also algal coverage. And inside the EcoBoot, there are also other important devices, such as the SBG, which is simply a motion sensor to account for picture roll and ebb movement and correcting the echo sounder data. And we have also a DGPS rover, which obviously is strictly a DGPS, but can use it also with a normal GPS. In this kind of data that I'm gonna show you, we use simply as a GPS rover. And we have also a quick cast, so we can, if we need, we can deploy samples or CTDs to acquire more measurements. These are the specification of the echo sounder. So it's a 204 frequency with a fixed beam angle of 8.5 degrees. And you can use this echo sounder from 0.5 to 100 meters. So it's practically easy to reach almost the shoreline in this with this application, with this device. For ground truthing, this is the ROV. Is a customized Blue Robotics Blue Rob 2, which is used to acquire some video and photo of the substrates. You can see coralligenous bioconstructions and Posidonia oceanica meadows in front of the Civitavecchia area. And also other photo. This is photo from raw video really close to the harbor new entrance, new infrastructure. So let me go inside the data, and this is the survey plan. Yellow lines are USVS survey lines. And blue dots are scientific diver control point for vegetation, 8 remotely and randomly chosen. And yellow lines are different in the area close to the harbor and more denser in the area south of the harbor. We made this simply to test the accuracy of the measurement and how the data analysis can be done if you have denser or less denser survey areas. So in the panel 2, you can see a snapshot of the eco-sound and profile using the visual aquatic software. So this is what the raw data of each of the surveys appear, and then these can be analyzed to know what is the bottom and what is the algal or vegetation coverage. So first information that we achieve is the bottom morphology. In this kind of application, we start from 1 meter, less than 1 meter from the depth from the shore, and to almost 18 meters of depth. Generally, this is as a heterogeneous morphology, and the areas close of the harbor show an increase of the depth gradually from the coastline to the offshore, as normally can be. But in the areas southern of the harbor, there is a shallower areas, and there is also the deepest area of the survey plan, which reach almost 18 meters. It is quite strange and really close to the coast, but I'm going to explain you why the presence of this morphology in the next slides. So second important information that we can achieve is the bottom type and biocenosis types, or characterization of the important biocenosis of the area. So this is what we have done using all the data and applying kriging interpolation. So in the deepest area, we have coralligenous bioconstructions. The brown is vegetated rocky bottom, and obviously sandy color means sandy bottom. And sandy color is strictly in the areas where in the previous slide we saw the deepest area of the survey. And coralligenous bioconstruction were found over the depth of 12 meters. Sandy bottom was located, as I said, in front of this place that's called Borgo de Scalchi. The presence of this sand is due to the deposition processes of sediment suspended in water column, which found a depression area that is present due to local coastal dynamics. And also this depression is strictly in front of big stream in the area, in the mainland. In the panel C, you can see raw images related to some coordinates 1, 2, and 3 in the panel B. One is coralligenous bioconstruction near the area where the new port infrastructure will be constructed. 2 is like this, in this place is close to the shore, and is Posidonia oceanica on rocky bottom. And also we have a photo like in the same place where there is Posidonia oceanica meadows of algal coverage of genus Asparagopsis. I want to show you this kind of algal coverage because all these data were acquired in January. So this algal coverage can reach the same height of Posidonia oceanica meadows. So we have to test this and have a strictly ground truthing observation to manage what our ecosounders say this Posidonia, what our ecosound say this algal coverage. So for this reason, in the previous slide, I show you the 8 ground truth scientific diver observation for measuring height and presence and coverage of plants instead of algae. So these are some other images of the plans of ground truthing, and in the upright there is the plan of ground truthing activities strictly related to the construction of the new harbor. So in the green you can see the scientific diver routes, so 2 routes there, 4 routes there, and the lines means in this area we made some video acquisition by ROV. This is the map of the coverage and the the 8th of Posidonia oceanica meadows. So we speak about strictly plants. We can keep these not accounting the algal coverage, putting a threshold inside the data analysis, which for us is 20 centimeters, and this threshold was chosen by ROV images and diverse measurement. So maximum coverage found in this area of Posidonia oceanica meadows is 40%, and in January the maximum 8 is 0.4 meter. We try also to test the goodness of our data, applying some correlation, linear regression, and Cohen's K coefficient. So we have that our measurements are strictly correlated with diverse measurements with a 0.8 R and with a p-value less than 0.01. And also our data, ecosounder data and diverse data fit with a linear regression model with a R squared of 0.75. And also, finally, the Cohen's K identify a value from 0.5 to 0.6, which highlight a Moderator substantial agreement of our measurement. Specifically, regarding the Renove project, the characterization of the bottom typology and present absence of vegetation cover has been used to evaluate the impact on new port structure on the habitat. So you can see there all the vegetation. So this map is submerged vegetation coverage accounting from algae and plants. Using the threshold and analyze the data with the 20 centimeter threshold, you can see this, that is the new structure, and this is the presence of Posidonia oceanica in the area. So new structure maybe does not affect directly the meadows. So in conclusion, I want to show you some future perspective and what we really want to do with this kind of approach. Obviously, this is not listed in this list, but we are planning to do more campaign to extend our data in all the Latium coast. And all these things are done for supporting the environmental restoration actions of important ecosystem. But I really believe that one of the important things that CMCC can have with this kind of approach is the numerical modeling data validation also in the areas really close to the harbor, because I want to precise that this is an USV and ROV plan to habitat mapping, but we can customize our vehicles with what the needs of the research need. So we can put CTDs, put some other kind of sensor that can be used to validate numerical modeling data. Also, one of the important things that we can do in the coastal areas is seafloor litter census of several marine litter items, also of small dimension, using new customization that we are planning to do with this USV. And also our map and data can be used for archaeological surveys. So this is the reference, and thank you for your attention.
Thank you, Daniele. Very interesting. So there are no questions for now, but I have one, just a curiosity. Which are, in your opinion, the challenges to transfer these results, this application also in a wider area? I suppose costs, because you mentioned at the beginning, the cost of the different tools and methodologies, but are you planning with your group also to look at different areas in the Mediterranean region, Mediterranean Sea, or also in other areas?
Yes, absolutely. Speaking about the cost, I'm pretty sure that is more cost friendly to buy 2, 3, or 4 autonomous platform than do regular survey using oceanographic boat or small vessel for coastal areas. But the second part of the question, yes, we are planning to do more and more investigation, not only in the Latium cost. I've only speak about Latium cost to relate this presentation about the Renore project, which is mainly what I have to do for my work. So, but I am inside other important project of national and international importance, in which we are gonna apply in the next months this technology in several parts of Italy.
Okay, are you also planning a scientific publication of these results, I suppose?
This absolutely yes. These results are all, I've promote this type of approach in several conferences, but now I'm working on publication on scientific peer-reviewed journal, but I'm not gonna show you the preliminary result of that, because I'm gonna work on that more and more. Also, there is a possibility to apply machine learning approach to analyze this data, so it's quite challenging.
Okay, just a very quick question before reading the ones that are coming. You mentioned in the future plan also archaeological studies.
Maybe.
Yes, but are you already planning which areas?
No.
But just an opportunity
No,
that you can
it's only
follow.
a future perspective. So I think this kind of investigation can be useful and have good data to relate with archaeological things.
Okay, now there are 2 questions. One is from Ani Shalabi. I'm sorry if the pronunciation is not good. The question is, are these equipment cost effective to be included in ENV, I suppose is environmental impact assessment surveys and studies?
I think yes. I have to answer writing, or I can answer by voice.
You can answer now, but also
Okay.
writing later if you want.
Thank you for the question, Annie. And yes, are cost effective, and also this depend of the customization of the USVs. So if you have, for example, you can have an instrument to use in 100 campaigns for maybe 50,000, and if you want to do one single oceanographic campaign, you need 30,000 for one campaign. So yes, I think it's cost effective.
Okay, another question is by Justin Wayne. Could the approach be used to assess the greenhouse gas content and or emissions in coastal habitats?
Thank you, Justin. And I'm not quite inside the GHGH content, I don't know, but thinking about using sensors or instruments to quantify these, and you can put these on the USVs, and yes, you can do this. I think no problem. But of course, I'm not inside this kind of research.
Okay, another is by Cristina Lavecchia. In Renovate project, will you analyze also impact of future climate change scenarios on marine habitat in relation to Civitavecchia next extension?
Thank you, Cristina. Yes, there is a big modeling part in this project. Will be done with the OPA division and with the help of the other partner, which is the Bologna University. So yes, there are quite big things to do in terms of climate change scenarios.
Okay, now again, Justin, could the approach be used for coastal conflict management and resolution?
Thank you, Justin. Conflict management and resolution. Management, resolution, I don't know. We can acquire data for the management. Then if you can use this data to plan some strategies that are need to the resolution, maybe, but data that coming from USVs and remote operated technologies are strictly for the characterization, so for the management.
Okay, thank you. Now another couple of questions. One by Joao Rodriguez. Have you considered complementary tools like, for example, environmental DNA collection and analysis for biodiversity monitoring in coastal areas? Using USV as sampling methods is becoming quite common, and the data is complementary to acoustic and satellite collected data.
Yes, thank you, Joao. I know that now is quite a big things using USVS. So also for this reason, I'm gonna work in this field. And I'm not inside the DNA studies. So yes, I think there are now, I'm pretty sure there are now DNA collection samples that can be used directly on the sea. And maybe you can install this in USB, maybe, but I'm not inside this kind of research.
Okay, now another question by Gemma Aiello. Do you know the examples of coralligenous bioconstruction and habitat mapping offshore of Punta Licosa in Campania region?
No, I've never been there, and I never do surveys in the area that you mean. I know that there is coralligenous bioconstruction, but I don't know nothing about this.
Okay, maybe you can also exchange after the webinar with the Gemma. I don't know for now. Now other question, but if you want to go in detail about something that maybe you missed it during the presentation because of time, if you want to explain better something, we have.
No, there is another question from Francesco. Ciao, France. And
I'm sorry, just now.
Yes, but I can answer.
Okay.
You talk about the GPS positioning. It's enough for high resolution coastal mapping and siting in sensitive habitat. What is the method used to relate acoustic and diverse surveys? So, Francesco, no, maybe you can. It depends. It depends on what you have to study. If you want simply a photo of what you have behind the surface, you have to use maybe a simple DGPS. But if you want to accurate measurement, obviously you need an RTK DGPS positioning. So, but in this kind of study, I don't use this kind of positioning. For the divers and for the ROV, we have for the ROV we have an underwater acoustic positioning system which consists of receivers and transmitters. So we have the receivers on the boat and the transmitters on the ROV. And the divers, to acquire the coordinate of the divers dives, we use their positioning launching a signal from the bottom when they dives, and then we acquire the positioning in this signal.
Okay, so I don't know if there are other questions coming. Just give time to participants to write in the chat. Okay, Cristina Lavecchia, it could be very useful if in Renovate you produce a guideline for a PNRR project. Like I don't remember now the explanation of the acronym is the do not significant harm, I think, and kind of impact evaluation.
I really appreciate the suggest, Cristina. We are gonna thinking about that.
Okay. So we can wait a couple of minutes if there are other questions coming. I don't know if in the meantime, Daniele, you want to add something?
At the moment, no.
Okay, just because of time, maybe you
a little bit
was fast in your
yes.
presentation, but if you want to add something, please. Okay. Okay, in any case, I want to remind you that the webinar will be circulated through the CMCC social network, and you will find the YouTube channel of CMCC. And also you can, of course, write to Daniele if you have some additional question also later when we close this webinar, okay?
Yes, please write.
Okay, if there are no more questions, I think that we can close here. Okay.
Thank you very much for your assistance.
And thank you for your attention. Have a nice day.
Have a nice day.
Bye-bye.